Students, now we will see some of the examples. Here we have first question which is given. So to find the total charge on 5 electrons. So we know that what is the charge carried by single electron? Single electron carries the charge of 1.602 into 10 power minus 19 coulombs, isn't it? So this is the charge carried by single electron. Okay, so the question is to find the total charge on 5 electrons. Means 5 electrons will carry total of how much charge will be carried by 5 electrons. Okay, so the total charge carried by 5 electrons we have to calculate. So for that thing, given thing is what? N is what? Number of electrons. So that is 5. 5 of the electrons are there, and we have to calculate the total charge Q. Okay, so we know that charge carried by one electron is this much. So we know that total charge Q will be equal to what? Minus Ne. So that N is number of electrons, E is the charge carried by one single electron, and this minus sign indicates negative. Sign indicates what? So negative charge. So electron charge. It will indicate us. Okay. Yes. So here we have to put on the values. So n is equal to 5 into 1.602 into 10 power minus 19. We have to give out, and after multiplying this, we will get the total charge carried by 5 of the electrons. That is equal to what? Minus. It is the sign given for negative charge. Means what? Electron charge. We will indicate its so and so. Okay. So it is 8.01 into 10 power minus 19 coulombs. Is the total charge carried by 5 of the electrons. Okay. So one electron gets this much charge into 5 if you do. So that will give you the total charge carried by 5 of the electrons. Okay. So very simple problem. Okay. Yes. So second problem here we'll see what is that? We'll see the question first. Find number of electrons flowing in a conductor in 1 second. Okay, so in 1 second, so we have to calculate the total number of electrons flowing through a conductor. Okay, if 5 amperes of current flows through it. Okay, so we have a conductor wire. So we have a conductor wire. Here, 5 amperes of current is flowing. Okay, so the current is measured in amperes, isn't it? So 5 amperes of current is flowing through it in 1 second. In 1 second. Okay, so now what we have to do is 5 amperes of current is flowing in 1 second, and our question is to calculate how many electrons are there. How many electrons are flowing to make 5 amperes of current in 1 second through a conductor wire. Okay, so that is our question. So it is very simple here. So T is 1 second, given thing, isn't it? T is equal to 1 second. So we have to calculate the number of electrons, and we have to calculate. Okay, so we know that I is equal to Q by T. So this is like a formula like we have gone through, isn't it? So what is current? Current is what? It is rate of flow of charges. Rate of flow of charges. Rate of flow is what? With respect to time. Okay, so rate of flow of charges means total number of charges flowing in 1 second will give you the total current, isn't it? Yes. So that will give you current. Okay, so how much current is flowing through the conductor or whatever the thing it is there. Okay, so now the rate of flow of charges is equal to what? Current. So I is equal to Q by T. So here we will write. So Q is what? Again we will write Q is equal to what? Minus N into E. So minus N into E divided by T. Okay, so if I rearrange the things, I is equal to minus Ne divided by T. If I rearrange the things, I will get the equation for N. So that is what we are going to write here. N is equal to I into T divided by E. That is equal to 5 into 1. 5 is what? 5 amperes of current into time is equal to 1 second divided by E is what? Charge on 1 electron. So if I do that calculation, so we will get 3.12 into 10 power plus 19 electrons. So these many electrons will make out just 5 amperes of current. Okay, so these many electrons will flow through the conductor wire in 1 second to make 5 amperes of current. Fine? Is that okay? Yes. So this is how we have yes. So this is about the current, the electron calculation and the charge calculation. Here we'll see some of the example wherein here we'll be seeing for the Ohm's law application. Okay. So here our question is to find the voltage applied to circuit having 5 kiloohms of resistance. So we have to calculate what the voltage applied to a circuit. Okay, so how much voltage we have applied to a circuit, and that circuit is having 5 kiloohms of resistance. Okay, load. Okay, so we have a load resistance of 5 kiloohms. Okay, in that circuit, and the current flowing is what? 2 milliamperes. Okay, so 5 kiloohms of resistance is there in that circuit. Okay, load, and the current flowing through the circuit is what? 2 milliamperes. So now we have to calculate the voltage applied to that circuit. Okay, so they have given the resistance and they have given the current too. We have to calculate voltage. Very simple. Okay, given things are what? I is equal to 2 milliamperes, R is equal to 5 kiloohms. So we, by Ohm's law, we know that V is equal to I into R. So we know that, isn't it? V is equal to I into R. Current flowing through the circuit is directly proportional to the voltage applied. Okay, R is the proportionality constant, that is what? Resistance of the circuit. Fine? Yes. So now here we have to put the value of I and R. So I get the voltage done. Okay. So here 2 milliamperes, 5 kilo ohms. So that we have to concentrate on. Okay. So now you people are aware of kilo, isn't it? So in some stationery shop, in some grocery shop, if we go, so we will order for 1 kilo of sugar. Okay, so 1 kilo of some dal, something and all. Okay, so that is all we will be ordering, isn't it? So what is 1 kilo? So how much grams will make 1 kilo? So it is how much grams will make 1 kilo? It is 1000 grams. 1000 grams will make what is that? 1 kilograms. That is kg. Okay. So 1000 grams equal to what? 1 kilograms. Instead of writing 3 zeros, so we will use these representations. Kilo, milli, your milli is some other unit. Okay. So kilo. Then we have what? Mega, giga. In your memory cards and all, you will aware of so much of GB, so much of MB. Okay, so MB means what? Megabits. GB means what? Gigabits. Okay, so this is how we will be going to calculate the memory measurement. Okay, so it is measured in what? Bytes. Okay, so many bytes of memory we will be calculating the thing as the memory calculation is made in the basis of on the basis of what? Bytes. Okay, so here for weight we will be going for grams, isn't it? So for memory measurement we will go for bytes. So if it is so much of we have RAM, 2 GB RAM, we will be talking about 2 GB RAM. What is 2 GB? In the sense what? 2 gigabytes of RAM we have. Okay, 2 GB. Okay, so that is the multipliers are set with some representation. Okay, so that will simplify our representation. So here instead of writing 1000 grams, we will use 1 kg, 1 kilogram. 1 kilogram means 8 times. Okay, so 1 kilo means what? Kilo is the multiplier 10 power plus 3. 10 power plus 3 grams. 10 power plus 3 grams. Kilo means what? 10 power plus 3 in the sense. So here we will have the decimal point, isn't it? After 1000 here we have decimal point. So what we have to do is, so we will go 3 times back. Okay, so once, twice, thrice. 3 times we will go back. So that will make what? 1 into 3 times we have come back, isn't it? That is why multiplier is what? 10 power plus 3. 1 into 10 power plus 3. You will write it as. Okay. So 1 into 10 power plus 3. So that is what we will go for. It is represented as what? 1. 10 power plus 3 means what? It is denoted as what? Kilo. Kilo, we will write this as, okay, instead of writing again 1 into 10 power 3. Again, to simplify this thing, we will use what? We will use what? 1 kilogram, we will write it as, okay. So kilo means what? 10 power plus 3. Okay. So what is that? Kilo is what? It is 10 power plus 3. So then we have what? It is kilo. Kilo. We'll write it as what? K. Okay. So then mega. Instead of writing mega, we will write it as what? Capital M. So that is what? 10 power plus 6. So then we have giga. Instead of writing this, we will write G. So that is equal to what? 10 power plus 9. These are the multipliers given with some name, so that it is helpful for us to write the representation in a very brief manner. Okay, so this is why we will be using all these things, and we have to aware of all these things. Okay, so kilo is 10 power plus 3, then 10 power plus 6 is what? Mega. Giga is what? 10 power plus 9. Okay, so likewise we have what? After giga, we will have what? Terabytes, we will say it as, isn't it? So terabytes will be written, it is 10 power plus 12 is terabytes. Okay, yes. So tera is the multiplier. Okay, so byte is the measurement thing. Okay, so here we have our kilograms. On the basis of grams, we will be weighing the weight. So that is why when we go to a grocery shop, we will order for 1 kg of sugar. Okay, so that's all. Okay, now this is all about the multiplier. So again, here we have what? Milli. Milli is what? Milli is what? Milli centimeter. Like we have what? Millimeter will be going for, centimeter will be going for while measuring the length. So we will be going for millimeter. So many millimeters of something will be measuring it as, okay. The length will be measuring it what? Millimeter. So what is milli? Milli actually is what? Negative multiplier. Okay. So it is, if I say 2 milliamperes of current means what? The current, if the current is 2 milliamperes, that means what is 2 into 10 power minus 3. Milli is what? 10 power minus 3. Centi is what? 10 power minus 2 is what? Centi. Okay. Centimeter is what? 10 power minus 2. Okay. So milli is what? It is 10 power minus 3 multiplier. Okay. So this is 10 power minus 3. We will write it as what? Milli. Small m. Okay. Yes. So 10 power minus 3 multiplier. If we are using, then it is represented as what? 10 power minus 3 is what? Written as what? Small m. That is milli. So then we have what? After milli we have what? Micro. Micro is 10 power minus 6. Micro will represent it as something like this. This symbol will be using micro. Okay. So it is micro. This symbol will be using milli and okay. So this is milli will represent it as what? Small m. Micro will write this representation for micro, and then after this, so we have another thing as what? Nano. Nano is what? 10 power minus 9. So small n will be using for the representation. Okay, so nano is what? 10 power minus 9 multiplier. Okay, so the multipliers are given some name so that we can identify them and we can write the representation in what? In very brief manner. Okay, so this is how we will be going for the multipliers. Milli is what? 10 power minus 3. Whenever we come across milli, so we should know, like we have to get the thing in our mind as what? Multiplier is what? 10 power minus 3. Whenever we go for micro, we have to make sure in our mind it is 10 power minus 6. Whenever it comes nano, 10 power minus 9, we have to make in our mind. Okay, so this is where we will be going for the things. Okay, so now we will see. So now it is what? 2 milliamperes. Current is what? 2 milliamperes. That means what? 2 into 10 power minus 3 amperes. And current resistance is what? R is equal to 5 kilo ohms. 5 into kilo means what? 10 power plus 3 ohms. So this is what we have to go for. And if I put these values here, that is I is equal to 2 into 10 power minus 3, that is milli, into 5 into 10 power plus 3. So now 10 power minus 3, 10 power plus 3, if I multiply, both will get cancelled, isn't it? So the thing will be 5 into 2, that is equal to 10 volts. 10 volts of voltage we have to apply to make 2 amperes of current through a circuit having resistance of 5 kilo ohms. Fine. So this is an example where we can use Ohm's law. Okay, so Ohm's law equation. Okay, so now we have another question given. Find the current flowing through. Here we have to, like, our question is to find the voltage. Now we can shift the question in a different manner so that to calculate the current. Find current flowing through a resistance of through a resistor of 100 ohms when 20 volts of voltage is applied. Okay, so when 20 volts of voltage is applied to that circuit and that circuit has got a load resistance of 100 ohms, so I have to calculate the current. Okay, so we know that what is the voltage we know, and what is the resistance we know. So that means what? The third thing is what? Current calculation. We can calculate it very easily. So we know that V is equal to I into R. If I rearrange things, I will get the equation for I is equal to V divided by R. So V value is what? 20 volts divided by resistance is what? R is equal to 100 ohms. So here there is no kilo thing, isn't it? So current will get 100 ohms. Okay. So if I divide the things, so I will get it as what? 0.2 amperes. 0.2 amperes of current will be flowing through that particular circuit when we have 20 volts of voltage applied, and if that circuit has got a resistance of what? 100 ohms. Okay, so that is all about on this question, and you people can try your own values for resistance, current, and you can go for all the things calculation. Okay, so even if I give some for example another question, maybe to calculate the resistance. So to calculate the resistance, okay, if I give you certain voltage and current, if I have some, for example, 10 volts of voltage is given, and if 5 milliamperes of current is flowing, okay, so voltage is what? 10 volts, and current flowing is what? 5 milliamperes in a circuit. What is the resistance? So we know that R is equal to so we have to calculate R. This is our question. Okay, so there is a question given. Okay, so the voltage applied to the circuit is what? 10 volts. 5 milliamperes of current is flowing through the circuit, and our question is to calculate the resistance. Okay, so our question is to calculate the resistance. Okay, so by Ohm's law we know that V is equal to I into R. So if I have to go for the resistance calculation, so R is given as what? R is equal to, it is V divided by I. So that is V is what? 10 volts divided by 5 milli. 5 milli they have given milliamperes. 10 power minus 3 it is, isn't it? So 10 power minus 3 milli calculation. Okay. So then if I go for the like a solution, so 5 ones are 5 twos are, it is 2, and this 10 power minus 3 multiplier, if it goes to the numerator, from the denominator, if it goes to the numerator, the thing will become what? Plus 3. Here it is minus 3 in the denominator. If I take it to the numerator, so then this minus 3 will become what? Plus 3. So this is how I can go for 10 power plus 3 it is now. Okay, so that is what it is, 2 into 10 power plus 3. 10 power plus 3 can be said as what? So many ohms, and 10 power plus 3 is written as what? 2. 10 power plus 3 is what? Kilo, isn't it? 2 kilo ohms of resistance is there. Okay, so this is how I can go for voltage calculation, I can go for current calculation, I can go for what? Resistance calculation on the basis of Ohm's law. Now here we have some question to calculate the total resistance when resistors connected in series and parallel. So here our first question is to find the total resistance of the series combination of resistors 10 kilo ohms, 20 kilo ohms and 50 kilo ohms. 3 resistors are been given, or 3 resistance values have been given, and these three resistances, they say that these three resistors or resistances are connected in what? Series combination. So we have to calculate the total resistance. Okay, so we can go for the solution. So given R1, so we can name the resistors as what R1, R2 and R3. So R1 is 10 kilo ohms, R2 is 20 kilo ohms, R3 is 50 kilo ohms. You can take in any manner. Okay, so you can take this as what R3, this is R2, this is R1, no problem. Okay, so R1 is equal to 10 kilo ohms, R3 is equal to 20 kilo ohms, R3 is equal to 50 kilo ohms. I have taken, and to calculate total resistance, we know that total resistance RT is equal to what? RT is equal to, when resistors connected in series, we have this formula. RT total resistance is equal to sum of all the resistances, isn't it? So RT is equal to R1 plus R2 plus R3, that is equal to 10 plus 20 plus 50 kilo, isn't it? It is 10 kilo ohms, 10 kilo plus 20 kilo plus 50 kilo. So we can have the result as what? 80 kilo ohms of resistance. Total resistance RT or R effective also we can call it as, isn't it? REF. So R effective or R total we can call it as, it will be equal to what? 80 kilo ohms. So now we will go for another question to find the total resistance when three resistors or three 30 kilo ohms resistances or three 30 kilo ohm resistors are connected in parallel. So what is our question here? So they say that to calculate, our question is to calculate the total resistance when three resistors are connected in parallel and all three resistors are of same resistance. So we have same resistance, means what? All the three resistors are of 30 kilo ohms of resistance. Okay, so we have three 30 kilo ohms resistances are connected in parallel. We have to calculate the total resistance of the circuit. Okay, so here now we have the solution. Given R1 is equal to R2 is equal to R3 is equal to what? 30 kilo ohms. All the three resistors are of what? Same value. So we have R1 that is equal to R2, that is equal to R3, that is equal to 30 kilo ohms. So total resistance can be found out using the formula, that is 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3, isn't it? So we have given 1 by RT is equal to 1 by 30k, 1 by 30k, 1 by 30k, all three values added together. So if we have to if we solve that, we will get the total resistance or equivalent resistance or effective resistance of what? 10 kilo ohms. Okay, so reciprocal of this. Okay, so if we calculate the thing, we will get the thing to be what? 10 kilo ohms of resistance. So likewise you can get you can take any of the values of resistances and you can calculate many examples so that you will be very clear about all these calculations. Now we will see about electric power. So electric power will be known as P. Okay, so now what is electric power? Electric power is the rate of doing work or energy. So I can say work as what? Energy, isn't it? So I can relate work because work and energy both are equal. So I can say what is electric power? Electric power is the rate of doing work. It is the rate of doing work. Okay? So how much work you are doing in, how much of rate of doing work with respect to time. Okay? So electric power is nothing but what? It is the rate of doing work. I can both work and energy both are equivalent, isn't it? So I can also define electric power as what? Rate at which the electrical energy is supplied to the source. Okay, so the rate at which the electrical energy is supplied to the source. Okay, so in what rate we are supplying the electrical energy to the source. Okay, source is from where the electrical energy is generated. Okay, so it's given to the circuit. Okay, so the rate at which the electrical energy is supplied to the source, at the rate at which the electrical energy in the sense at what rate in the sense with respect to time, at what rate we are supplying the electrical energy to the source. So that measurement is nothing but your electrical, that is your electrical power. Okay, so more the electrical energy supplied, more will be the power consumed. Okay, so in that way we can go for the electrical power definition as what? it is the rate of doing work, or work and energy. Both means same, both are equivalent things. Okay, so the rate at which the electrical energy is supplied to the source. Okay, so that is said as what? Electrical power, or rate of doing work is also said as what? Electrical power. It is denoted as P. Okay, so now I can define in an equation form it as what? Like power P is equal to what? Work done W divided by time. Okay, with respect to time. The rate of in the sense with respect to time. Okay, so work done, it is represented as W divided by time T. So or energy supplied divided by time. Okay. So we can write it so and so, and it has so and so, and power is measured in what? Watts. Okay, so electric power is measured in what? Watts. W will write it as, and work done will be in joules and time in seconds. Okay, so if I have to go for the equation, so I can write the same thing as P is equal to W by T. W is work done divided by T time. Okay, so power is measured in what? Watts. Okay, so much of watts of power will say it as. Yes, now it is W by T. So if I multiply and divide by Q, so this if I multiply and divide it by Q, the charge. Okay. So now this will be what? W by Q, and this will be what? Q by T. If I multiply and divide by Q, charge, and if I rearrange the things as W by Q and Q by T, so then if I have to go for these two terms separately, so what is this? Work done in moving so much of charge is nothing but the voltage, and it is amount of charge, or the total number of charge moving in so much of time. Rate of flow of charge is nothing but your current, isn't it or not? Rate of flow of charge is nothing but current, and amount of work done in moving so much of charge is called as what? Voltage. So in that way I can write the electrical power as what? P is equal to V into I of so much of watts. Okay, so power P is given as what? Voltage into current. So we have already dealt with this, isn't it? Power is nothing but the product of voltage and current. Okay, so the voltage, how much of voltage you have applied and how much current is flowing, so that product is nothing but your power. Okay, so our electrical power we can say it as. Okay, so now we'll see power dissipation in a resistor. Power dissipation means what? Power consumed. Power dissipation means what? Power consumed in a resistor. So we will see what is the power, like how much power will be, like the amount of, like we will see the power, how much power will be dissipated or how much power will be consumed by in a resistor. We'll see here. So power dissipation is power consumed in a resistor. We'll see. So what will be the power dissipated, or what will be the power consumed, how it is going to happen. So when the current flows through a resistor, what happens is the electrons go strike with the atoms of resistor. Okay, so we have resistor has got atoms, isn't it or not? So these electrons, when current flows, electrons starts to flow, isn't it or not? These electrons go and strike the atoms of the resistor, so that they will collide, and colliding is what? Going and hitting. Okay, so with this collision they will give out the energy in the form of what? Heat. Okay, so when we rub our hands, so heat will be generated, isn't it or not? In that way, so when these electrons go and strike the atoms of resistor or resistance, so then the heat will be generated, or energy will be given out in the form of what? Heat. So this is called as what? Power dissipation, or power consumed in a resistor. Okay, so the energy will be given out in the form of heat. So when they go, electrons go and collide with the atoms, so they will give out, like it will be, the energy will be converted into what? Heat. So this energy will be given out in the surroundings, isn't it or not? Okay, so the device will get heated up. Okay, so this is wherein the devices will get heated. Okay, so we know that. So our mobile phone gets heated, isn't it or not? Okay, so this is all because of the current flow. Whenever the current flows, electrons starts moving, and whenever they move, they will generate heat. Okay, so they will give out heat, like they will give out energy in the form of what? Heat. So that the energy will be consumed over there. Okay, so in the form of heat. Or energy will be dissipated, or power will be dissipated in the form of what? Heat in a resistor. And here we can, like we know that in an equation form we can give out the energy or the power dissipated in a resistor. So we know that P is equal to V into I. Okay? So if I go for here, we know that power is equal to voltage into current. Now I can write this voltage as what? Voltage V is equal to I into R. We know that from Ohm's law. V is equal to I into R into I. Okay, so V is equal to I into R into I. We can write it so and so. So now I have written V, instead of V I have written I into R. Now if I multiply this, I square R will be the power. Okay, so the power consumed in resistance can be written as what? R. We can say it as what? I square R, or I square R loss will say it as. Okay, so I square R loss will say it as power consumed or power dissipated in the resistor is given as what? I square R. Okay, or like the square of the current into the resistance. Okay, so I can say it as, or also in the form of voltage I can say the power dissipated in the resistor. So P is equal to V. Instead of I will be writing I as what? V by R. So if I multiply this, it is V square divided by R. So V square divided by R is the power dissipated in a resistor. So P is equal to V square divided by R. I can write it as. Okay, fine. So now coming to electrical energy. So electrical energy is what? Or the electrical energy is represented as what? E. So electrical energy is nothing but the amount of power supplied or consumed. Okay. So the amount of power supplied or consumed in a certain duration of time. So the amount of and the power supply. So we have this electrical power. So to what duration we are supplying the electrical power, or to what duration we are consuming the electrical power. So that calculation or that measurement is nothing but your electrical energy. So it is the electrical energy is nothing but what? Amount of power supplied or consumed in a certain duration of time. So that will define the electrical energy as what? So and so it is represented as what? E. So in an equation form we can write, because we know that power is equal to W by T, work done by time. Okay, so this work done is nothing but your energy only. Okay, so they both are equivalent terms. Okay, so power is equal to W by T. If I rearrange the things, electrical energy is equal to what? It is W, that is equal to P into T. Power supplied in what? How much of duration? Power supplied in how much of duration? So that will give you the electrical energy. So electrical energy is measured in what? Joules.